I say the end, or is this a new start? Saturday, we're going to be talking about it, and I'll entertain any questions at this point, or we can go. Go ahead.
Of course, I think it's very good to have such an idea and this model. Of course, we don't know if there is generally a particle or there is some else or something like that. But I just have some small remarks to a foundation, to a Planck constant. If you can give back the slide, first slide with Planck constant.
Way back.
This is in the beginning. Yeah. I think that it could be precised that in fact in Planck constant we for sure, or it's in fact agreement of all physicists, we find no quantizing of the world or of course also of the wave. If you say about that frequency or energy is quantized, it is quantized because the atomic levels of electrons are quantized. But in general, the Planck constant is not bound only to this. We can have synchrotron radiation, and electron could radiate synchrotron radiation when it is accelerated in circle, and this spectrum or this electromagnetic are not quantized. Okay, so it can be generally said that in fact that at first that we have quantized frequencies or quantized energy, or that in physics we discovered that also Feynman agreed with this, and I wrote it also in my previous paper that Feynman also tried to say that we found no quantization or quantization in Planck constant. It's right as you say, in Planck constant we found a bound of mass, frequency, it is bound in Planck constant, that is all parameters in fact, and you can choose whatever parameter, you can choose frequency, you can choose length wave, or you can choose mass, and whatever of the characters, whatever of the parameters you can choose, you can continue, but in fact, for instance, with this equation, we can go from 0 to infinity. And it is a physical reality in the Planck constant.
Yeah, I'm not an expert in that, just to respond. I'm not an expert in the quantization of the energy. I just noted that when I did the equation for my intensity, and all of a sudden I had something that looked like Planck's constant.
In fact, you are right for the problems which you are solving, because you are solving that, but in general, we didn't find no quanta in Planck constant. And it was taught in the beginning, and it was taught when the Planck introduced it, but later it was not. That was the reason why, in fact, second quantization was introduced.
But your comment about frequency going to infinity, I'm not sure that I go with that. If you think of a sequence of particles, whatever they are, you're only going to get so many of those silly things in a wavelength. The higher the frequency, you finally get to a point, I think, where you can't develop a wave, or a frequency. So I think there's an upper limit, physically upper limit, based on this concept of particles being crammed into very small wavelengths. On the other hand, I think you can go all the way out to 0 for gravity, because you can have there's no limitation on squeezing. You can put as many particles in a wavelength that's as long as a building. It's pretty easy to do. So the upper limit there may be a limit. It may be stopping at gamma or somewhere up there. I think you know. Doug?
Okay. At page 44, at the beginning of your article, this is section 2, the particle theory of a wave. And you've got the particles being more dense and then less dense, more dense, less
It's like
dense.
it's a linear density.
Yeah. Do you have in mind that the wave continues right on through the particles as the density of the particles expands and contracts?
If the particles continue, they only, when they interact, they may drop out.
Do they need to continue? Do they need to continue? Can you have actually a wave going through particles where the particles are generally in place, like a water wave, for example?
So can this, well, gravity has to go through lead. I'm not, you know, it's going to go through that very dense structure of lead and come out the other end. Now, where is it going through? How is it really interacting? I'm not sure, but most of them go through. But for gravity, a portion of them, or at least the intensity of it, however that intensity is reduced, has to be reduced if gravity is going to be a pushing force, pushing objects together.
Well, for example, in the other article, Paul Schroeder and one other, don't you have most of the radiation from the sun, for example, being trapped right at the surface of the Earth?
Yeah, no, you know,
The long wave,
radiation goes through.
going deeper, much deeper.
Yeah.
Yeah. So I'm talking about radiation generally and being at a frequency. So presumably, if this diagram you've got of expanding and shrinking density would apply to all the radiation from the sun, whether it be short wave or long wave. Would that be so?
Except it's not expanding, contracting. It's a wave, and it's a fixed wave going through, and the densities, the distribution of that density, linear density, is the same as it goes through. It repeats, but it's the same. In this case, I hate to say it, there's no ether.
Well,
the ether is gone because the particles themselves become the thing that's moving.
well, just on that, you've got an arrow showing movement in that diagram. Now, you've got particles that move and a wave that moves. Do the wave and the particles move at the same speed?
Yeah. Well, there is no sine wave in the model. There's only particles. The sine wave is there to emphasize the density distribution.
Yeah. Well,
So there's a wave, but it's in the distribution of the particles, not in a continuous sine wave as we normally think about it.
It's a particle density wave. It's a function of the particle density
Yeah,
rather than a physical wave per se. Yeah.
yeah.
It's just a graph of the particle density.
Oh, so what you're still saying though, part of this is with the speed of light?
Yeah, we're actually suggesting that this particle be evaluated for gamma rays, visible light, and radio waves, and gravity, all four areas. Can you reasonably make a model that this still works somehow? And maybe even explain more that you couldn't explain before. One of the things that Dave particularly likes is the fact that it's not a continuous wave, and it's so much easier visually to visualize this red dot going all over the image of this room, and my face image all over this room, and they're all there right now, and not interfering. It's so clear, I mean, it's there, right? So how does that happen with a continuous wave?
So can your particles overlap each other in space?
I don't know.
What do you mean by overlap?
Well,
Occupy the same space? Well, we believe in regular laws of, no, you can't have things, if they can collide,
Well, I mean, you have waves, you have superposition in waves where two waves can go right past each other, and you can look at the density of the waves, you know, you have troughs and
Sure.
and hills and stuff, and they go right through each other, but
Right.
yet their energy goes through. Are we talking about all, you know, he's talking about the image of his face is being broadcast all around, and that these are particles types, so obviously are they going through each other? Are they occupying the same space at any point?
I'm still not, are you saying
Well,
that
it-
they're
it-
going
it-
like
Or-
this?
Yeah, are they going through each other? If his image of his face is all around the room, and he's saying they're particles, are the particles bouncing off each other, or are they passing through each other when they go?
They're passing by each other.
They're passing
Yeah.
by
It's
each
as
other
simple
or
as that.
colliding?
In general,
Because we don't believe that, you know, well, let me put it this way. That's actually a question we don't know because we're not talking about the properties of what these are.
Okay.
And that's one of the things when I'm going to talk about after he's done here. I'll touch on that a little bit.
When would you be talking, will that be today or tomorrow?
Today, right now, right after him.
to answer your question, when I do the math, I assume these things pass by each other without even interacting. This stream going across, these somehow are able to go by each other. They spread out or whatever they do without having to march, you know, to hit. Because if you hit and bend these things all over the place, mathematically in the model you get chaos. I can't make gravity work that way. It has to go in a straight line, and they can't interfere with each other. Now, is that true? I don't know if that's true, but that's what the model implies, and that's the simplest way for me to think about it, that they do just pass by each other for the most part.
How can they go?
Can we temporarily go back to the model that Dave was
You had to go to the other end,
where the
right?
line goes a curve around a ball, and it was the second to last.
That one, go right back. There you go.
There it is. I'll just make two comments. If there were an atom on the other side where it says David's model, and something tried to go around both of them, it's arguable, as I try to argue that maybe it speeds up, and maybe there is the Venturi effect, and maybe they attract relative to the pressures on the other side of them. And so then you would have, if something like this could happen, you would have a kind of, not the Lesage exactly where a particle bangs into an atom and shoves it in the direction of that particle's movement, but you would actually be able to have a background movement of gravitons or something that instead of going through it, if they tried to go around it, it would be squeezed if two particles were close together. Maybe
I remember your talk very well because Dave and I were sitting in the back. We both looked at each other and said, there's some sort of similarity to the fact that particles are going through, and whether these particles add to the cohesion of the protons and neutrons together in an atom, I wouldn't question. I was thinking, wow, there's a level of similarity there with what you're saying, what we're saying. I'm coming at it from a gravitational point of view, you're coming from it. In fact, this Venturi effect almost seems like there has to be something pushing those things together because of the low pressure caused in between. You got the outside pressure. It's not much different than gravity too.
I think that this is just an editorial. I think that the Venturi effect is less used in physics than it might be. It's an underused thing. The Poincaré objected to Lesage, whatever his name is, principle.
My discredited theory.
Arguing that generally when bullets go through things and they're somewhat slowed or stopped, they had so much heat that in order to get gravity, he felt that most objects would overheat. And in order to keep them from overheating, he had to assume that gravity traveled at, or the particle, if it went through, would have to, the bullet likely would have to travel at about 100 million times faster than the speed of light. Believe it or not, that didn't utterly disprove Boussage's because principle, because there are people, including Laplace, who entertain the idea that things may travel at 100 million times faster than light.
I was one of the ones who thought that initially until I did my paper on the Wang eclipse, and I finally had to conclude it's C. But there are three main objections to Lesage, and it has to do with aberration, drag, and heat. And actually, in the book, which I hope to finally get out at some point, I have a codified white paper that addresses those three issues. Heat is still the most difficult of the three. But for example, aberration is ridiculous because nature just doesn't aberrate. It doesn't do it.
I was going to say that I think the issue is really a lot simpler than we think it is. If you consider any solid that light can go through, like glass, if you're sitting out there as an observer and you're by the nucleus and it's about the size of Ray's chair, you won't even be able to see the electrons that are circulating it because they'll be too small and too far away if you're at the size that the nucleus is the size of that chair. Way in the high 90% of the space in an atom is nothing is there. And so it's very damn easy to get through an atom or a whole group of atoms and without ever hitting anything. However, those electrons out there that are so far away I can't see them are being held to this nucleus by an electric field. And what's going through is electric and magnetic fields pushing each other. At least the electric field, depending on its polarity relative to the fields it goes through, is going to be jerked this way for just a second. It'll go to be jerked that way. Comes to the next one, jerked. Assuming that the electrons are not, they're not in a rigid pattern, but assuming they're homogeneously on the large scale distributed, then those things will get jerked up as much as down and right as much as left, and they'll end up pretty much in a straight line, but it'll be a straight line that goes like this at the speed of light, and when it comes out at the other end, it's not getting jerked around anymore, so
You have to
it just continues at the same speed through the whole thing, but it takes longer because it's getting jerked around homogeneously in all directions getting through by the fields, and it never comes close to a particle.
You have to have a fast eye to see all that jumping around.
So what you've got that is very much that, except it's getting jerked every which way as it goes through what is mostly vacuum.
We're going to take one more question.
Oh, I'm sorry, go ahead.
The problem I have with what you're proposing, and it follows from the proposition just made, but goes in the opposite direction. You've got particles that traverse millions, if not billions, of light years in space. And they are crisscrossing all over the place. These are particles. How could they possibly avoid each other over millions and billions of light years of space? And then ultimately hit ordinary matter when they arrive here on Earth or at the sun.
I said because of the model, I treat it as if they're going in a straight line and don't interact. It doesn't mean I said that they wouldn't. Now, if you think about Lesage's theory in general, The gravity field around our galaxy is one way because of Andromeda over here. And so the particles coming from that direction are not the same as the particles coming from this direction. So I have an imbalance already before I get started. So how can I have this neat balance when I finally get down to the solar system where everything's so well behaved, but I have to admit there's inequities all over the place. The probabilities of these interactions are so small, and I'm doing the calculations right now. I cannot give you a number, and I'm not confident yet. The probabilities of these interactions are so small that these incidental interactions may change directions of various particles, but mean nothing to the main flow of gravity coming towards our solar system, even though you've got these imbalances, and even though you may have random occurrences. In my calculations of 150 digits, they're down here, and I'm still trying to figure out if 3 digits has got the right number. You know, it's minor. For example, we say in the other paper, these particles come from the sun. Well, they must come from our sun. And from stars, it must come from our sun. So there's particles coming from our sun pushing everything out. But that's one out of somebody, I read this number, 76 trillion of visible, observable stars in the visible unit, in our visible universe, 76 trillion. You lose one, who cares? As an engineer, I could care less if you lose one, because my digit's way out here at the 150 point. So these other things can happen, but my model has to pretend like the world is pretty, has nice even particles coming in from all directions, and they all go in a straight line, and they either interact totally or don't interact, they push or they don't push. Got to keep it simple. I got to keep it simple, because even with my mind, and I'm not stupid, it gets more and more complicated to keep track of random particles moving all over the place. So we start with a simple model. But I'll say this, Newton's model was even simpler. He makes a bigger assumption than I make with my equation, because he assumes all the masses in the center. My equation assumes the mass is distributed, and I account for where that mass is. But even that's simple, because it's a homogeneous sphere. Perfect sphere is homogeneous. So, but it's a broader assumption than Newton's assumption.
Okay, thank you very much. Sorry, I have to recreate what should have happened during. This is what you do in Hollywood all the time. Pretend you're saying something profound. Well done, that. Okay, thank you.
You coming back with it?
Yeah, I'm going to come back. Go on, you do it, you know how. Be quiet, okay? Okay, I'm just going to grab a slide, because actually during his talk I changed my slides. You talk about the digital age. Okay.
I missed the update.
No. Okay. Get the tall person. There you go. All righty.
So are we running?
You want to get it framed okay for the, because I did mess around with it.
Okay.
So started? Okay. Thanks so much. I'm going to talk a little bit. I actually piggybacked after off of my dad's paper. I was going to write a paper on metal and ether. Strange combination, but I think when Dad came up with this finding of his, I realized it was in line with that, but it was a bigger picture. I'd like to, before I start, put a few things in perspective that you didn't see that I saw before I got one of my rare wows during the last 20 years here. Dad was talking about speed of gravity. And one of the things is, before this talk, I had asked him to create a talk for the meetup groups, because we're making a prototype for meetup groups. We're making these slides, and we want it so that let's say you're interested in science and the CNPS, and you want to learn about gravity. Where's the slideshow for that? Where's the ones that talk about all the people who've done that, all the interesting things? Ether. We don't have those. We should. You know, how do people get interested? Go to your paper, find equation 47, and try to figure out what the heck that means. So one of our goals is to do that. So as much as only having 3 people, Saturday we'll have 7 now, in our local group, we're trying to get slides together so that if you're in a different part of the world and you say, hey, you should start looking at this group, we're talking about some great science. Well, what do you have? I made one of all the great scientists from the CNPS. I am absolutely amazed to this day, no one's gone there, open it up and see if your face is even on there and what I said about you. I could be talking really poorly about you. I could have chosen some person you don't agree with. I know this group doesn't have opinions, but I know no one's opened it up and looked at it, and I'm thinking to myself, I wonder what day it's going to happen, and then you know what kind of storm's going to hit. But the thing is that we're trying to develop these things, and my dad knows a lot about gravity. And he was talking about this, and this is what this wow thing was about. But before that, he talked about the speed of gravity. And there are 2 things that he talked about. The Wang eclipse, and that is when the solar eclipse happens, you have a gravimeter measuring gravity. It goes nuts right before and after the full eclipse. So it's full eclipse and it goes nuts, and then when coming out of it, it goes nuts again. Well, that coincides with light. And if you want to be a layperson, and this is Dad's way of making a layperson, when you stand on the beach at noon, you look up, and this is all hypothetical, of course, but this is the way it works. You look up and there's the sun exactly overhead, and you're at exactly high tide. The light has come to you in how long? 6 minutes or something like that, right?
8.
How long? 8.6, I don't know. And then when does gravity come? Same time. And this was a paper, I looked at his stuff afterwards. I went and started researching what my father was talking about. And sure enough, if you think about it, yeah, the sun's really over there, about 2 degrees, right? But you're seeing the sun above you. But the information's taking you 8 minutes. And guess when the high tide is? Exactly at the same time. What's the conclusion of the speed of both? C. It's not 10 billion times C, it's C.
There's no delay in the high tide?
No,
Yes.
this is just a hypothetical thing. But if you look at Wang's eclipse, you are doing it not by calculating. People don't go out to eclipse and say, okay, I'm putting my telescope over 2 degrees because the sun's really there. So what happens is the Wang eclipse is a much better real measurement because you have a gravimeter reacting at the exact same time the light is. So what's the conclusion? And then when he went into that, and then he told me and talked about, well, light is basically, it's pressure coming at you. That's all it is. If you have an equal amount of ether or gravitons, same thing, then they're just sitting there. If you then make it in different pressures, and it's coming, boom, boom, the pressure's hitting you, it's not coming because they're bouncing. But that's one of the reasons. Anyways, gravity and light, that was really important. The other thing is, I want to make sure you guys understood, is gravity 1 and gravity 2, or ether 1 or ether 2. I recommend highly you read Neo-Mechanics by Glenn Borkert, whether you agree with it or not. It's infinity, and it basically says all fields, whether or not, what level you're talking about. Galaxies are particles in a field of something bigger. Gravitons or ether is a field that keeps gravity going. That's why stars don't go flying off the edge of galaxies. They should. Why? Is there magnets? Are there little strings holding them? No. What happens in water you're going to see here. That's what that is. So gravity, what we're saying, that maybe not have explained it real clearly, but gravity one, that is, if ether is causing gravity and its light's encoded as the density changes, that's what he's saying, then for it to curve around and refract, it has to bend, it has to go somewhere. And the only way to do that, it's either hitting something or there's something else. But the reason we think there's gravity 2 is because we think that ether, or gravity 1, I call them the same thing, are whirling around. That's what causes, and we have physical models of how that works. But for anything to whirl around, again, it's not magic. It's got to have a force keeping it there. So the idea of small mass, it could be galaxies, it could be planets, it could be subatomic particles, it could be gravity 1, gravity 2, ether 1, ether 2, doesn't matter. It's moving mass forming a gas-like thing, and that's what keeps things going around other things. And for ether particles to be bent into electric fields, they're going to have to be something below that. And that's why we subscribe to the infinity, because we don't believe it's different from what you subscribe. But I will say to you, too, Duncan, that we can still talk about Hackathon 1.1 and the models, because it doesn't matter. We don't care what it's made of. If we go there, as you know, you're going to go nuts. We're already having a hard enough time working with ether, let alone what ether is and how it's made. We still have to get what excuse my language, a freaking atom looks like. That's what Hackathon 1's going to be. So we can still talk a lot of very interesting things and still disagree on that. Okay, well, let's go forward here. Big surprise was in July, I guess it was June, time flies fast, CNPS local meeting, Bob showed his wave particle model. I was floored. I've been floored many times in 20 years looking at dissonant science, and I'm going to actually show you, and these are truly wow moments in my life. 1994, Dr. Karazani's work where he showed that special relativity had a physical and mathematical flaw. That is, when you talk about 2 reference frames, that's illegal both in math and in physics, because in math, 2 reference frames, go look them up, autodynamics.org, he shows very clearly mathematically that 2 frames are redundant. They are useless. The second frame is useless. You cannot include it mathematically or physically in a system. The way I say that in layman's terms, there's one 3-dimensional space. You can move the origin, but you can't have one origin here and one origin here. It doesn't make any sense. If you don't believe me, 9 physicists in 1994 at TRW Space Park, where I worked in the Artificial Intelligence Lab, took his calculations, 3 weeks, went away, came back, and declared to me, and that was a wow moment. He said, David, I have the letter too, I don't have it here, I could have showed it to you. We cannot find any problems in what Karazani has found. And that was very profound to me. That means that the physicists couldn't argue against his equations. In fact, they said his equations have a potential of generalization of the theory, but we're not into proving theories. And of course, they don't want to show Einstein wrong. No one wants to do that. 2008 was another big moment. I went on the internet and saw a big gap there. I had a lot of fun, I guess, between those. Neil Adams' Expanding Earth video floored me. After 2 minutes, I looked at that and it just changed my world. I just couldn't believe it. It made so much sense. I said, at that point, I was a convert, and I got to know him and work with him. I got him to the MPA to write stuff. He's a pretty brilliant guy, even though he's a millionaire, and got his money from drawing cartoons of Batman. Brilliant guy. Then the other one was in the new cycle theory by Borkert and Putz. More the Borkert side. It wasn't too thrilled about the cycle theory, but that's my own opinion. But I read neo-mechanics, and that blew me away. You're talking about all the levels of the universe going up and down, infinity. I believe in infinity. I believe that parts can't be partless. But the neo-mechanics and the way that works, I recommend everybody looking at that. That blew me away. Then Lionel Deneu's underwater cylinder. I had seen something actually around 2008. Lionel Deneu was in the first video conferences before many of you knew that they were going on. We were doing them sort of by ourselves, and I'm going to show you that. And then again, hit me about the same velocity was the gravity model, where you said, oh, well, I'll talk about it. That hit me. What I believed before June 2005, fields are clouds of small forces, still believe that. No one had a viable solution to the wave-particle duality. That's what hit me most. When my dad showed me that, I saw for 20 years looking at great scientists in the NPA, CNPS, looking at that and never saw anything that was nearly not satisfying. And no one had, to my satisfaction, come up with a model of gravity and light. And then, of course, I also knew that Bob the Hilster observation gravity moves at the speed of light is correct. Things that bother me, things that were solved, collisions of ether. Now, this is exactly the opposite of Duncan. I was laughing at Duncan because I said, man, he and I, and Dad actually answered both questions. It's statistics, right? But I always had this problem that the reason I see this light from a star 10 billion light years away is because something has collided. Keeps going, goes 10 billion light years. That, to me, is much harder to explain than the opposite. And I'm not sure we're really talking about really statistics that just blow your mind anyways. I mean, that's a long way. Whether they're collisions, which they could be, or whether they're traveling, it's still mind-blowing. And my dad says, well, it's the statistics. And if you look at neutrino statistics, or you look at what my dad's doing with ether, it's quite doable. Neutrinos, get this, they don't exist, but neutrinos, they say, go through 100,000 light years of lead without interacting. So thinking about a particle going through 10 billion light years of pretty empty stuff compared to other stuff isn't too hard to believe. So that was my waves in an ether or cloud of ground that bounce off each other. Didn't sit with me either. I always had this problem. The biggest thing that, I think what hit me when Dad told me this, and I just jumped off the couch because I couldn't live with this idea that this was going on with light. I couldn't see gravity and light being, nothing was making sense. Nothing. I couldn't make a model in my head with that. Until he basically said, well, gravity is coming at you. That is, if you look at the force over time, it's equal. It doesn't matter if it's really here. In fact, it may cause, gravity is not it's the amount of gravitons coming at you, and it's hitting. And then the light itself are just the density of that. So if you have something really dense, and it answers a lot of questions. This was actually my diagram, because my dad was talking about with numbers. I'm an artist, I can't see that. So I quickly drew this up, and it makes a lot of sense. So if you imagine here, while you were talking, Dad, I put these slides in. So here's something, an antenna. One of the things is, here, let me give you a photonics expert at the University of Connecticut about 10 years ago, was at one of the MPA conferences. He gets up and he stands. I studied light for 35 years. I'm a person, photonics expert. He says, this is what we know about light. Light is emitted somewhere in the universe. How that happens, we have absolutely no idea. It then travels through the universe. How does that happen? We have absolutely no idea. Then it comes to us, it comes to our lab, hits our detectors, which we know is detecting it. How does that happen? We have absolutely no idea. Now, if you think about it, that's pretty amazing. That's the reason I guess he was standing in our conference, not afraid to say that. You go to the mainstream and say, people are shocked when they ask me, well, what do we know? We don't know what light is. We don't know what gravity is. We have some ideas. But that's what's going on. This thing, it blew, when my dad told me this, within an hour, my head was exploding with all these ways things work. An antenna. Okay, we think that electricity is light. Electrons travel how many feet per meter per second? How many meters per second does an electron travel?
The antenna?
Huh?
The antenna, you mean?
Yeah, no, I'm talking about electrons in general.
Electrons in
Like in a wire, electrons in a wire.
Electrons in the antenna, it's about millimeters.
That's electron drift you're talking about.
Yeah, that's electron, yeah. So regardless, I know from the people, at least I've talked to, who are experts in this, that the problem, we have a big problem with electrons and electricity and the speed. And if you look at it, Glenn Borchert's work on neomechanics says that what's happening, and this is my paper on light and metal, is that it's not electricity, it's not electrons, it's light. Why? Here's some examples. What happens when something goes wrong and you see a power thing happen? What happens? Light. What happens? It's traveling at the speed of light. How coincidental? Why are electrons traveling at the speed of light? When they decay out of radioactivity, they go at 0.87 the speed of light fastest. So why is that? So imagine, and I thought to myself, this is really stupid, because I'm still struggling with it, because it's so darn simple. It's either simply amazing or simply stupid. But if electricity is light, and light is density changes in ether, well, what are we doing? We're pulsing it, it's going through it, and if metal, which is my contention, has special properties that it can contain ether because of its atomic structures, therefore we have Hackathon 1.1 to figure out what the heck is going inside atoms to find out why ether is bent by atomic structure. That's where we need to go. Well, then this thing, what's happening? Current is coming up here. Current? Well, current is, well, it could be ether or gravitons, whatever you want to call it. And these things are, metal has a property of containing or letting out. It's controlling it somehow, and it's causing these pressure changes, or it's actually launching them. Whoops. Or it's actually launching them out there. That's really sad. Imagine if that, what's really happening in the physical world is that what's happening with antennas, we're just launching ether out of metal. I mean, that's, and if you think about it, the problem is it makes so much sense, it's scary, like I said, or it's totally crazy. Just think about it. I mean, it's going to bug you for a while. It's bugging me still. I don't have the answer. That's why we're going to have a hackathon. Okay, here's another one. Light is changes of density, okay? Of course, we can have changes of density, many of this. I mean, you can have all kinds of light, X-rays and everything going through the same space. You can have that, it's no problem. But why is it that they'll go through? Because if they cause gravity, they're going to go through, right? They're going through the mass. But if I'm above here and I'm laying up here inside, and I know there's a big space here because one of my degrees is in architecture, so we have probably a space enough to stand up here. If I'm up there, why isn't the light from here going through that? Light, if it's only the change of density, somehow between here and there, almost all of the gravitons or ether or picogravitons, we're going to have to come up with a name for this and finally get it. It's either ether or graviton, I don't know. But come up here, why is it that these